Hi everybody. Today we're looking at end behavior of rational functions. End behavior of rational functions. Okay, so the question we're asking ourselves is, when we talk about end behavior, we're talking about what happens to the function as the x values become very large or become very small. Okay, so what's happening as x approaches positive or negative infinity. Otherwise, as x becomes very big or very small, what does the functional value approach? Okay, that's the question. As x approaches positive or negative infinity, in other words, as the x values get very big or very small, right? What's happening with the function? In other words, what's happening with the y values? Okay, again, uh, y is equal to f of x or p of x, right? So as x becomes very big or very small, are the y's getting also very big or very small? Or are the y values approaching a certain value? In other words, here's your choices. Is p of x, the y values, also approaching positive or negative infinity? Or is p of x approaching a certain value, a certain number, right? Certain value. So that's what we're trying to find out. And if p of x approaches a certain y value, then we call that y value an asymptote. Okay? So if it's approaching a certain y value, we call that an asymptote. All right? A horizontal asymptote. So a horizontal asymptote. A horizontal. Okay? So let's take a look at this. Sorry about the messiness here. Um, so let's work on this. Now again, one way that we can determine or try to determine asymptotes is by, of course, graphing, right? And then seeing what's happening as the x values get very big or very small. So that's the first thing we're going to look at. All right? Again, graphing is the easiest way to do it, right? As long as the graph is showing us, something that's understandable. That's not always the case. So here, I'm just going to record my steps. So again, let's go into the graphing function, and we're going to erase everything out, and then we're going to copy this function. Now, when you're doing this with your calculators, if your calculator writes everything on one line, you have to make sure to put parentheses. All right, I'll do it here just to emphasize it. You have to put parentheses around the entire numerator and denominator. So 6x, so 6x minus 12x raised to the ninth power. Okay, let's drop that out. Okay, like this. So you have to put parentheses around the entire numerator and around the entire denominator, especially because they're multi-term expressions. Okay, or else you're going to get the wrong answer. And then again, we put parentheses around the entire denominator. 3x to the third, like so, plus 7. Like that. Okay, now I didn't have to do this because again, my calculator shows it as a fraction, but if your calculator does not, if it writes everything on one line, you have to put parentheses around the entire numerator and the entire denominator. All right, now, so press enter. Okay, now that is in. Now let's just take a look at it using our standard viewing window, which is again Shift F3 viewing window, right? If you press Shift, you only get one choice, viewing window. And then if you press standard, which is F3 again, mine is already set to standard, right? Negative 10 to positive 10, negative 10 to positive 10. All right. And now it's set on standard. Let's take a look. So there's my function. All right. And as you can see, As the x values get very small, as the x values go to the left, the y values are now increasing, correct? So as x approaches, so I'll write that over here, as x approaches negative infinity, the y values are growing, so the y values, or the p of x values, approaches positive infinity. To the right, as the x values go to positive infinity, the y values are now going down, right? They're decreasing. So now the y values are approaching negative infinity. So as x approaches positive infinity, the y values are, as x approaches negative infinity, the y values are approaching positive infinity. As the x values are approaching positive infinity, the y values are approaching negative infinity. All right, just for curiosity's sake, I'm just going to zoom out. So I'm going to press Shift, zoom out. So I want to take a bigger look, a larger look, and it's the same thing. All right, so same thing's happening. So let me zoom back in here. Okay, just like that, and same thing, right? So, okay, so it says find the horizontal asymptote of P. So as we discussed, the only way that we're going to have a horizontal asymptote is if the function approaches a exact value, a y value. In this case, it's not, right? The function is approaching negative infinity as we go to the left, and as we go to the left, it's approaching positive infinity. As we're going to the left, it's going to positive infinity, and as we're going to the right, it approaches negative infinity. So there is no exact one value of y that it's approaching. So in this case, we're going to say the graph does not have a horizontal asymptote. And that is correct. Okay? Let's do another one. Okay? So here, again, we could do the same thing we did, which is graph this, right? We can graph it. So let's graph it. Let's get rid of it. Delete it. And then I'm just going to type it in. Let's do it again. 5 x cubed minus 3x plus 4. Again, if you don't have this type of fraction bar in your calculators, make sure everything is in parentheses, right? The top is in parentheses and the bottom is in parentheses. Okay? 10x cubed minus 7. Like that. All right? So there's my function. And now again, I'm just going to make sure it's on standard viewing window, and I'm going to take a look. Now, can you see this? And I'll actually zoom in a little bit so you can see a little better. So Shift, zoom in, enter. Okay, guys, so you see this, right? You see that even though there's something going on here, right? It looks like at x equals 1, there seems to be a big gap here, right? In the function. It's disconnected, right? So, but however, we're not interested in what's happening at x equals 1. We're interested in the end behavior. What's going on with the function as x gets very big, as x goes to positive infinity, and as x goes to negative infinity. Clearly, we can see in this situation that the function starts to level off. The function is leveling off as we go in both directions. So it looks like definitely in this situation, we are going to have a certain y value. We're going to have an exact function value. Question is, what's that value? So if I want to have a little idea, I can always plug in a number here, right? Let's plug in 5. So let's Shift, G solve, continue. And we're going to calculate what the y value is. We're going to plug in x equals 5 and see what the y value is. It looks like it's going to be around a half. So let's plug in 5 for the x, and sure enough, it's 0.493, which is about 0.5, right? So it looks like the y value is around half, or 0.5. Let's plug in another value. Let's plug in negative. Let's plug in negative. negative 5. So shift, G solve, continue. Let's calculate a y value. I'm going to plug in negative 5 this time and see what I get for a y value. And sure enough, it's 0.48, which is pretty close to 0.5, which is half. So it looks like we're going to have a horizontal asymptote, an imaginary horizontal line here, where the function is not going to cross, correct? And that line is going to be the value of the function at the ends. Okay? However, so we can find it this way. It's going to be about 0.5, but there's another way to do it. And this is the way to do it here. All right? If you look at the function and you ask yourself, as the x values get very big, right? In this one, they're asking for only one side. As f of x approaches positive infinity. So as the x values go to the right, as the x values keep going to the right, what is this function going to approach? Well, if the x values get very big, right? For instance, as I discussed in class, if you win a lottery ticket for $1,005,000, so let's say you hit the jackpot for $1,005,005, you get a check, and the check only says $1 million on it. Would you get very upset because you didn't get the $5? Absolutely not, right? I mean, $1 million compared to $1 million, $5 is really nothing. So probably you would be satisfied with the $1 million, right? Likewise, if the x values get very big, let's say the x values go to 1 million, do you think these numbers here, plus 4, minus 7, are really going to be significant to your value for the function? Right? Same thing. This term, 5x cubed, imagine 1 million cubed, right? Compare that with 3 times 1 million. This is going to be much greater than this term here. So as x approaches positive infinity, we can approximate the function, right? Instead of writing all this out, we can approximate the function to be, this term's going to be insignificant, this term's going to be, that term's going to be insignificant. The only terms significant are going to be 5x cubed and 10x cubed. So we basically just pick one term in the numerator and the denominator that is going to be significant compared to the others. So this is our new function as x becomes very big. And we can always simplify this, right? We know the x cubed is going to cancel. We know that 5 goes into 10 twice. So this whole function basically simplifies to 1/2, which confirms really our results graphically, right? As x approaches positive infinity, the y values approach about 1/2. As x approaches negative infinity, again, the y values approach roughly 1/2. So here is an algebraic way that you can find that asymptote, that horizontal asymptote, right? So let's pick our choices, and there's our answer right there. And that is correct. Okay, guys? So again, I want you to think about it in both ways. Graphically, okay, so visually, we can kind of see whether the y values, whether the function is getting very big or very small, right, as x approaches positive or negative infinity. And we can also calculate it algebraically, all right, just like I showed you here. All right, guys? All right, take care.